by €1. It's bought. €1 one.
Well, who bought this one?
Oh.
Maybe she had.
To improve our life.
Yes, she had extra money.
Yeah.
All right. Okay. Let's have a look at the homework. Materials. Young's Modulus. You tried it, yes? You tried? Did you try it? Yeah.
Why?
What happened?
You broke your laptop?
No. You're so nervous you broke your laptop?
Yeah.
That's what I thought. What happened to your laptop?
I don't know, no laptop mental.
Okay. Okay, whatever. Right, let's have a look here. Okay. A 1 meter rubber wire is hung from a table. How thick is it if 100 grams cause it to extend by 1 centimeter? Okay. So what you have here, where's my pen? Oh, come on. Come on. You can do it. There we go. Right, so number 1. Bit slow. Bit slow. So this is 0.1 kilograms.
Wow.
I know. And it extends by 0.01 meters. And we don't know the area here. But we know the force is 0.1 G. Multicolored. Right. Okay, so we can use the formula. Young's modulus is stress over strain. Now, let's see. We know the Young's modulus for rubber. Can you tell me what it is for rubber?
0.1
Yeah.
times 10 to the power of 9.
Okay. The stress is the force
The area.
over the area, and the strain is the
S over L.
extension over the natural length. Do I give you the natural length? Yeah. Of 1. Okay, so we can solve this to get the area. Let's do that.
The area is pi r squared, right?
Huh? Oh yeah, I'll get the area first and then say it's pi r squared, yeah. Right, so I got a very small area, as I should. 9.81 times 10 to the minus 8. So pi r squared equals the area.
So 9.81 times 10 to the power of 97.
What? Do you want to double check? I'm not finished though. This is the area. So then the radius is 1.76 times 10 to the minus 4 meters. So the diameter is 3.53 times 10 to the minus 4 meters. And that's the answer. Let's make it millimeters. 0.353 millimeters is what I got. What did you get?
0.1.
0.1.
And then 0.00
Alright, hang on, I'll double check. 0.1 times 10 power 9
I don't.
times 0.01 divided by 0.1 divided by 9.81. Oh, oops. Right, it's not an 8 here. What did you say? You were right. That's 7. Sorry, this is wrong. So you have now the radius is the area divided by pi square root. So that's 5.59. No?
No.
Oh, hang on, something's wrong with me.
Maybe, I mean, I could be wrong.
Okay, I can live with that. 9.81 times 10 power minus 7 divided by pi square root. Yeah, the radius is 5.59 times 10 to the minus 4. Maybe you're right, Grace. So the diameter is 1.18 times 10 to the minus 3. So that's 1.18 millimeters. You got this?
I got 0.02 meters.
1.
1 meter?
I forget my unit. I forget.
Okay. Well, anyways, this is the answer.
Oh yeah.
What?
5.5. I don't know what I got. I don't know how I got it.
Ah, it's okay. Okay. Continue.
Should we get a young modulus in the exam?
Which exam?
Final exam.
Oh, will they give you the number? Yeah, usually they do.
Usually.
Well, no, what I mean is, sometimes they give you the information and ask you to calculate Young's modulus. But most of the time, they give you the Young's modulus and you need to use it. Like in this example. Okay, continue?
Yeah.
2 meters glass of radius 3 has 1 kilogram placed on the top. How much should it contract by? Okay. So, what did I say the radius was?
2 meters.
The height is 2 meters, yeah?
3.
3 centimeters, okay. And there's a force here of,
1 kg.
is it 1 kg?
Yeah.
So there's a G force down. Yes. Right, so Young's modulus is stress over strain. So what's Young's modulus for glass?
70 times 10 to the power 9.
70 times 10 to the 9. Stress is force over area, which is pi r squared, over strain, which is extension over original length. Is the radius 0.03 or the diameter? Wop, 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 wop.
The radius.
Okay. Right, so you can solve this to get the x. I got a really small number.
11.
What did you get?
9.91 times 10 to the power -8. Is that good?
No, but your number's different. Let me double check. 70 times 10 power 9 divided by G times pi times 0.03 squared divided by 2. If I multiply the top and bottom by 2, and then flip it. Okay. Yeah, what did you get her in?
9.91.
Yeah. So if you solve this, you get delta x equals 99.1 nanometers. How big's a nano?
10 power negative 9.
Yeah.
And then G divide pi divide by 0.03.
No, this is the final answer. Are you here? Yeah, g divided by pi or squared. That's the Grace. That's the stress. Okay. X? What do you mean? This? No. This is the stress and this is the strain. Yes?
Okay.
Here, look, no, Grace, look. Stress is force over area and strain is extension over natural length.
Yeah, I mean, I don't understand what I'm doing yesterday.
Okay. Do you understand now?
Yeah.
Okay, good.
Nanometer?
Yeah, the answer. -9. Okay. Next one? Yeah. Steel wires support a lift. The lift has a mass of 1,500 kilograms. If the wires are 2 centimeters thick and there's 4 wires, by how much should the wires extend if 2 60-gram people enter the lift?
One, two, two.
No, too late for that. Oh. Mysterious text message from somebody I don't know. Hope you are well.
YouTube.
Yeah, you did. Weird. I have a stalker.
Are you sick?
What?
Are you actually sick?
Am I sick? No. Why would you think that?
Because that
Hope you
message
well.
is dead. Hope you
Oh no, that's an Irish expression. Just hope things are well with you. Yeah. Oh, you didn't hear this before?
No.
Ah, okay.
I hear people say grand a lot.
Yes, grand would be the answer. Yes. Ah, you know this word.
No.
Ah, no, Grace, no. You must have heard people say this in Ireland.
Dr. Lorraine says it a lot.
Ah. And check.
No, you can't check it. It won't be in the dictionary, right?
Why?
You know this word. Do you know this word? You don't know this word? In Ireland, people say it a lot.
Yeah, but I don't understand.
It's like, how are you?
I'm great. Something like that.
Yeah, I'm grand.
Ah.
I'm fine.
Yeah. It's quite flexible. Depends on the context. How was the homework? Grand. How are you feeling? Grand. You can have different levels. You said Lorraine says it a lot. Yeah, okay.
Don't tell her I said it.
I'm sure she knows she says it a lot. Okay. This is okay, Grace.
Yes.
This is grand. Yeah? Yes? Yes, okay. Alright, next one. The lift is 1,500 and the wires are 2 centimeters thick and there's 4 wires. Okay, so what you have here, you have your lift. and you have the 4 wires, and then the people enter the lift. Now, what?
People.
Yeah, yes, 4 people. Now, there's a little trick to this question. How much does the lift weigh? What's its mass? 1,500, isn't it?
Yeah.
But the lift already moved because of its 1,500 kg. So in fact, I don't need to care about that when the extra people come in. Do you know, if you can picture it like this, first we have the wire, okay, then we have the lift, and the lift makes the wire go down a little bit, and then the people get on the lift, and then it goes down a little bit more. I only care about this in the question. I don't care about this, and I don't care about this. I only care about this part. So in fact, you can forget about the 1,500 if you want. It's only the extra extension from the 4 people that you care about. Okay? Right, so what material is this? Steel, is it? What's Young's modulus for steel?
200 times 10 to the power of 9.
Yeah? And then the formula is stress. How heavy is each person?
Oh.
What? What? You said -9?
No.
What?
200 multiplied 10 to the power 90.
90? Goodness. How heavy are the people?
60 people, if 260 kg.
Oh, there's only 2?
Yeah.
Oh, not 4. Alright. So that's 120 G. Now, the area is 4 times pi. And what's the radius? 0.01 squared?
This, the wire is yeah.
Yeah. Okay, so we want to solve this for x, basically. Right, start again. So I get extension is 4.68 micrometers. What you get?
3.3.
What unit? 10 to the minus?
5.
No.
I don't know where I'm on.
Okay. Calculator maybe?
I don't know. I should remove everything.
No, maybe it's just a calculator. Did you get this part, Grace? And did you
Wait.
did you use 0.01 or 0.02 for the radius?
0.01.
Oh, good.
Maybe second. Huh?
It's 2 people, Hareen, isn't it? 60 kg?
60 kg each.
I don't know then. That's what I got. What did you get?
I counted the list.
Ah, no, I understand, yeah. Well, no, hang on, Hareen. You counted the lift with the people. And then you could do the lift without the people. And then it's the difference. Do you know?
Yeah. Okay.
Yeah. So you did it the lift with the people. Then you could do just the lift, and it's the difference. You can check if you get the same answer.
Okay.
Should be the same.
Okay, wrong.
Ah, simple problem then. Okay. Is this okay? Yeah, next one?
Wait.
No, okay.
1.18.
ate too much for breakfast. I had 2 bowls of porridge.
2 what?
2 bowls of porridge and a yogurt. Because I had breakfast at home and the bus was so quick, I had like half an hour, so then I thought, I'll go to the canteen and get a second breakfast.
Wow.
That,
Why?
so I won't be hungry. Now I'm too full. Okay, next one, Grace.
Why here this one multiply divide divided by 1?
Why this one?
Yes.
This is the strain and this is the stress. Right. Yeah. No. Stress. Strain. Yeah? Yes. Okay, next one. Let's have a look. An unknown material is used for hanging a weight. When the weight is of mass 1 kilogram, the material extends by 1 millimeter. And when the weight is 1.5 kilograms, the material extends by 2 millimeters. What's Young's modulus? Okay, so need to fix it? Or you're just messing? Right, in the first case, how much is the weight? 1 kg. And then the extension?
1 millimeter.
1 millimeter. And then the second case?
1.5 kg.
1.5 kg?
And the extension is 2 millimeters.
2 millimeters. So you could make a graph here if you wanted. For example, here you could put stress, and here you could put strain. Do I tell you how thick the rope is?
No.
Oh dang! I should have told you that. Okay, anyways, you don't know the area here. So in the first case, the strain is 1g over area, and in the second case, the strain is 1.5g over the area. And in the first case, what's the stress? No, what am I saying? This is the stress. This is the stress. Yeah? This is the stress. Okay, here what's the strain? The strain did you say 1 millimeter, was it? Or 1 meter?
Millimeter.
1 millimeter, okay. So the strain is 1 millimeter over the natural length, and here the strain is 2 millimeters over the natural length. Okay, so the first one, that's 1g over A, and that's 1 millimeter over L, and that's 1 point here. And then the second one, that's where is it? 1.5g over A, and then here is 2 millimeters over L. That's the second point. So what is the slope of this line?
That.
Young's modulus. Yeah? that's what we want. So Young's modulus would be 2 millimeters over L minus 1 millimeter over L over 1.5 G over A minus 1 G over A. So that's 1 millimeter over L over 0.5 G over A. Zero point 002 times A over L. But because I didn't give you the A or the L, yes?
Do you go to that side?
Yes. Go to the top. So, in the first case, it's 1 kg. Let me put it in green. So the stress is 1G over A. That's the force and that's the area. That's okay?
Yeah.
In the second case, the stress is 1.5G over A. That's in the second case. In the first case, it extends 1 millimeter, and in the second case, it extends 2 millimeters. So in the first case, the strain is 1 millimeter over the length, and here it's 2 millimeters over the length. So this is the stress, this is the strain. This is the stress, this is the strain. And I can make a graph. Here's the stress, and then here's the strain. So I'll put this and this here and here, and then the strain, this and this, goes here and here. So I make 2 points, and the slope is equal to the stress over the strain, which is the Young's modulus. Yeah. But this question, I can't finish it because I didn't tell you the A and I didn't tell you the L. So let's pretend I did tell you. So let me say that the L is 1 meter and the A, I don't know. Let me make up a number. Let's say it's that. So let's pretend I gave you this. Or, I don't know. Oh no. Wait, stop. Stop. I have it backwards. This is the stress. The stress should have been this number and this number here. And this is the strain. I should have used this number and this number here. So it means it's upside down.
So it's just one of the lines.
Yeah, so easily fixed. No, I fixed it. So sorry, the answer should have been 1 over 0.002 L over A. My graph is wrong.
Well, this is strain.
No, I wrote stress, that's right, but stress is this number. I put the wrong number here. I should have put them down below. Terrible. Right.
So strain is 1G over A.
Now that's stress, 1G over A.
Yes.
And these numbers are wrong. I should have written like 1G over A and 1.5G over A. And here I should have put these numbers. This one and this one. I should have put here and here. I wrote the wrong numbers down. Do you want to change it? I'll rewrite it here, sorry. Okay, let's be careful. Here, strain. Here, stress. The first one is 1G over A. No, it's not, I did it again. Hang on. Here, 1G over A. Yes. And here, 1 millimeter over L. Yes. So here's the first point. Then the second one, what's the 2 millimeters, isn't it? Over L. And here, 1.5G over A.
Stress is the one when the weight over A, right?
Yeah, which is this.
Like,
Yeah. So don't worry, Irene, I'll make sure I get it right the second time. So it should look like this.
okay.
Yeah. Okay. Continue?
This is
Yeah, nearly there. So, if I go back, oh sorry, do you need to write this down? So my answer here, did you write this down? I didn't give you this in the question. So if I type this in, 1 over 0. So the answer is, Young's modulus is 1592357. .59 megapascals. Sorry, that was a mess. Messy.
too much.
Much mess. Okay, next question. Okay, that's the last one, I think. Ah, yes. A boy hangs 200 grams at the end of 2 meters. The wire is 1 millimeter thick. He pulls it down by 1 centimeter, and then it quickly moves up. Alright, so this is 2 meters, and here we have, how heavy is it? 200 grams? What did I say?
200 grams.
200 grams, 0.2 kilograms. And what material is this? Steel, is it?
Yes.
Steel. Okay. So, Young's modulus is stress over strain. What's it for steel?
200 times 10 to the power 9.
Stress is force. Now, I give the area as 1 millimeter, isn't it? Is that the radius or the diameter?
Diameter.
Right, so that's pi 0.001 over 2 squared over strain, which is extension. How much does he pull it down?
1 centimeter.
Wait. No, this is a waste of time. Yeah, I don't need to do this. Because I know everything. So, I mean, we know that this is 1 centimeter, and we know this is 2, so what? There's nothing in here to solve. Right, so what we can do is we can change the formula a little bit. Young's modulus is force over area over strain. Do we have another formula for force?
Mass times acceleration.
Yeah, anything else? This is stress, this is strain. Do we have any other formulas for F for this topic? We do. Come on. No, you didn't. Come on, he was in Peter Pan.
KX.
Hooke's law. Yeah. So you can replace the F with K delta X over A over delta X over L. Now what happens here? They cancel. So you get K equals Y A over L. Okay, let's calculate. Um, 2 meters. 7,853.
K equals. Never mind.
So now I have the K. Is that okay? So now that I have the K, I can know the time. Do you remember the formula for the time? 2 pi root m over k. Zero 0.01 seconds. So how long will it take it to go from the bottom to the top? It'll only take half of that time. So the answer is 0.005 seconds. Or if you want, that's 5 milliseconds. Yeah. Yeah. Can I close this?